iba't ibang klase ng tunog o sounds sa ating paligid. Minsan, ito yung mga music na ating pinakikinggan araw-araw. Minsan rin naman ito yung mga tao na nag-uusap sa ating paligid, yung mga taong tumutugtog ng gitara o iba't iba pang klase ng instrumento, yung mga taong tumatawa sa ating paligid, at minsan naririnig din natin yung mga sasakyan na umaandar sa kalsada. Ano nga ba ang ibig sabihin ng tunog or sounds na naririnig natin araw-araw sa paligid? Ang sound or ang tunog is the sensation perceived by the sense of hearing. So this is perceived through our ears. Nalalaman natin na merong tunog or sound kapag naririnig ito ng ating tenga. Since nalaman na natin kung ano ang ibig sabihin ng tunog or sounds na naririnig natin sa ating paligid araw-araw, ngayon naman, aalamin natin kung ano nga ba ang epekto ng temperature sa pagdaloy ng tunog or sounds. We are going to discuss about the effects of temperature to the speed of sound. Since nalaman na natin kung ano ang ibig sabihin ng sound or tunog, pagdating sa science, specifically sa physics, ang sound ay isang wave. So meaning to say, sound is a wave. Sound wave can be described by 5 characteristics. You have the wavelength, the amplitude, the period, the frequency, and the velocity or speed. Meaning to say, these are the characteristics of a sound wave. During your grade 7 level, you have studied the different kinds of wave. So, pinag-aralan ninyo kung ano-ano ba yung mga iba't ibang klase ng wave. Meron tayong dalawang klase or 2 kinds of wave. You have the transverse wave and the other one is the longitudinal wave. Now, sound wave is a longitudinal wave. What do we mean again by longitudinal wave? So this is the movement of a longitudinal wave, meaning to say, ganyan din yung paggalaw ng sound wave. The longitudinal wave moves with a series of compression and rarefactions. The compression and rarefactions are found in a longitudinal wave. So for us to easily understand what is compression and rarefactions in a longitudinal wave, we have to identify saan ba makikita sa longitudinal wave yung compression at rarefactions. You can see in the picture, we have here a longitudinal wave. So, nasaan ba ang compression and rarefactions? So, ang compression, from the word itself, compress. Ito yung compression sa longitudinal wave. Ang rarefaction naman is yung maluwag na part ng longitudinal wave. So, ibig sabihin, ang isang longitudinal wave ay binubuo ng isang compression at isang rarefaction. Ang isang compression at ang isa pang compression ay equivalent sa isang wavelength ng longitudinal wave. So, since ang sound ay isang longitudinal wave, ibig sabihin ang sound wave ay merong compression at meron din siyang rarefaction. Now, since nalaman na natin na ang sound ay isang wave at ito ay isang halimbawa ng longitudinal wave, paano paano naman nabubuo or paano natin naririnig ang sound? So let us identify how is sound propagated. Sound is propagated through vibrations. Ano ba ang ibig sabihin ng vibration? Vibrations is the back and forth of motion of an object. So, ang vibration is ang pagtaas at pagbaba ng isang bagay. Kapag siya ay nag-vibrate, ibig sabihin siya ay nakakapag-produce ng sound. Halimbawa, yung mga drums, yung mga string ng gitara, ito yung mga halimbawa natin na kung saan kapag nag-vibrate yung object, ito ay nakakapag-produce ng sound. Sound waves is produced by continuous and regular vibrations. Ibig sabihin, kapag ang isang object ay nag-vibrate, it will produce a sound or it will propagate a sound. How does sound travel? So, since we already identified how sound is propagated, so meaning to say it is propagated through vibrations, now, paano naman siya nagta-travel or paano natin siya naririnig mula sa malayo? Halimbawa, paano ba natin nalalaman na meron ng tao sa labas ng ating bahay? Kapag tumunog na yung doorbell natin. Now, kahit tayo ay nasa loob ng bahay or nasa itaas ng bahay, paano natin naririnig yung doorbell na nasa ibaba ng ating bahay? So, how does the sound of the doorbell travels through our ears? The sound travels through air. So, yung doorbell o yung sound na galing sa doorbell, siya ay magta-travel sa hangin para marinig ng ating tenga kahit tayo ay nasa malayo sa pintuan. Sound wave is an example of a mechanical wave. Ano ba yung ibig sabihin ng mechanical wave? Ang mechanical wave, it requires a medium of propagation. When we say medium, kailangan niya ng sasakyan para siya ay makapag-travel. Halimbawa, tayo kapag papasok tayo ng school, minsan kailangan nating sumakay ng tricycle o kaya ng jeep para makarating sa ating paroroonan or sa school. Ganon din ang sound waves. Kailangan niya ng sasakyan or sasakyan para siya ay makapag-travel or para siya ay makapunta sa ibang lugar. Sound waves can travel through matter. So, ibig sabihin, ang sound waves, yung mga pwede niyang sakyan para siya ay makapag-travel, ay yung mga matter. Na ano-ano ba yung matter na pwedeng sakyan ng sound waves? Ito yung mga solids, mga liquids, at yung mga gas. Okay? So, ngayon, since alam na natin kung saan pwedeng sumakay ang sound waves para siya ay makapag-travel, tignan muna natin yung mga particles ng solids, liquids, at gas. So, yung particles ng solids ay magkakadikit, particles ng liquids ay magkakahiwalay or wala siyang definite na shape, at yung particles naman ng gases ay malalayo or sobrang layo sa isa't isa. Now, na natin kung saan pwedeng sumakay ang sound waves para siya ay makapag-travel, alamin naman natin kung saan pinakamabilis pwedeng mag-travel ang sound. So, para malaman natin kung sino sa solids, liquids, or gases ang pinakamabilis na makapag-travel ang sound, let's take a look back again at the arrangement of their particles. So, kung titignan ninyo, yung particles ng solids, liquids, at gas, malaki yung pinagkaiba nilang tatlo sa isa't isa. Sa solids, madikit or very tight. Sa liquids naman, walang definite shape and it's also close or not very tight from each other, while the gases are very far away from each other. So, kung titignan natin yung arrangement ng particles niya, mas mabilis mag-travel ang sound waves sa solids because of their particles or the arrangement of their particles. Magkakadikit sila and they only vibrate or ang movement lang na kaya nilang gawin is to vibrate. So, mas madaling makapag-travel yung sound waves sa solids. Since we've already identified what is sound and its characteristics, let us now discuss how does temperature affect the speed of sound. Pag sinabi nating temperature, ito yung init or lamig. So, ano ba yung epekto ng init or lamig sa pag-travel or sa bilis ng sound? Let's take a look at the picture. So we have here the different temperatures at meron din tayong mga particles. So dun sa una, dito, mababa yung temperature niya at ano yung movement na ginagawa ng mga particles. So mabagal yung movement ng mga particles kasi malamig yung temperature. Dito naman sa pangalawa, so medyo tumaas na yung temperature, medyo uminit na siya, yung movement ng particles ay bumilis ng konti. At dito naman sa pangatlo, siya ay may pinakamataas na temperature. Pansinin nyo kung ano yung nangyari sa movement ng particles. So siya ay mas mabilis or naging mabilis na yung kanyang paggalaw. So sa kanilang tatlo, ang may pinakamabilis na paggalaw ng particles ay yung may pinakamainit na temperature. Ibig sabihin, mas mataas yung kinetic molecular energy ng particles na merong mainit na temperature. Ano ngayon ang connection niyan dito sa sounds? Ibig sabihin, kapag ang temperature ay mataas, ang speed of sound ay mataas din or magiging mabilis. So kapag mainit, magiging mabilis yung speed of sound. Kapag naman mababa ang temperature or kapag naman malamig, ang speed of sound ay magiging mababa or mabagal. Ibig sabihin, ang temperature ay directly proportional sa speed of sound. Sound waves bend or refract when they travel through air or uneven temperatures. Kapag sinabing refract, nabebend siya or parang nababali. So, ibig sabihin, ang sound waves, kapag siya ay nagtatravel sa hangin, which is an example of a gas, it bends or refracts. Sound waves moving through air during the day are refracted upwards because of the warmer air near the ground. So, yung sound waves sa umaga, since mainit siya, mabilis yung travel ng sound, so nagkakaroon ng refraction, ang nangyayari, it is refracted upwards. So, pataas yung pag-travel ng sounds pag sa umaga because of its temperature. Halimbawa, ito yung ating picture. So, kapag umaga, mainit yung temperature or mas mataas yung temperature, so mabilis yung travel ng sounds, ang nangyayari, mabilis yung travel niya kaya mabilis siyang tumaas. So, ang nangyayari, hindi siya agad naririnig nung nasa baba or nasa mga tao sa grounds. At night, sound waves are refracted downwards because of the colder air near the ground. So sa gabi naman, since malamig ang temperature, yung sound waves, ang refraction niya or it is refracted downwards because of the colder air near the ground. So halimbawa, ito yung picture natin. Sa gabi, since malamig ang temperature, mabagal ang speed of sound, so yung refraction niya is downwards, kaya mas madali nating naririnig yung mga tunog sa ating paligid. Halimbawa, di ba pag sa gabi, pag nasa beach tayo, kahit nasa malayo na yung sounds or yung ingay, naririnig pa rin natin because of the temperature at night na malamig, and also the reason why nagkakaroon ng bending of sound waves paibaba. Kapag sa umaga naman, kahit nasa malayo siya, hindi natin siya naririnig agad kasi because of its temperature, so warmer sa umaga, and also yung speed of sound mas mabilis, so ang nangyayari, it is refracted upwards. The speed of sound in room temperature air is 346 meters per second. So, meron ding speed of sound ang room temperature, which is 346 meters per second. This is faster than 331 meter per second, which is the speed of sound in air at freezing temperature. So, kapag naman freezing temperature or ibig sabihin nun ay 0 degrees Celsius ang temperature, ang speed of sound ay 331 meters per second. For every degree rise in temperature, the increase in the speed of sound is 0.6 meters per second. At 0 degrees Celsius, the speed of sound in air is 331 meters per second. At 1 degree Celsius, the speed will become 31.6 meters per second. This is determined using the equation of V is equals to 331 meters per second plus 0.6 meters per second degrees Celsius multiplied by the temperature. So, merong temperature sa dulo or capital letter T. So, you have to remember the formula for the speed of sound is V is equals to 331 meters per second plus 0.6 meters per second degrees Celsius multiplied by the temperature. Which means that V is the speed of sound, while capital letter T is the temperature of the air. So, let us apply it in a sample problem. We have here determine the speed of sound on a cold winter day, which has a temperature of 2 degrees Celsius. So, using the formula of V is equals to 331 meters per second plus 0.6 meters per second degrees Celsius multiplied by the temperature. So, ano ngayon ang speed of sound? So, the speed of sound is that we're going to use the formula again, V or the speed of sound is equals to 331 meters per second plus 0.6 meters per second degrees Celsius times 2 degrees Celsius. Saan natin nakuha yung 2 degrees Celsius? Siya yung given doon sa problem. So, since meron na tayong formula at meron na tayong equation, pwede na nating mahanap yung speed of sound. So, 331 meters per second plus 0.6 meters per second degrees Celsius times 2 degrees Celsius. Para tama yung magiging sagot natin, unahin muna natin itong multiplication dito sa kabilang side. So, 0.6 times 2 degrees Celsius plus 331 meters per second. The answer will be 332.2 degrees Celsius. Another sample problem. Find out the speed of sound in air at a temperature of 22 degrees Celsius. So again, we're going to find the speed of sound. Using the formula of speed of sound, V is equals to 331 meters per second plus 0.6 meters per second squared. 0.6 meters per second degrees Celsius times 22 degrees Celsius. So, saan natin nakuha yung 22 degrees Celsius? Siya yung given dito sa problem. So, we already have the formula. Let us now compute for the speed of sound. Unahin muna natin itong multiplication sa kabilang side bago natin siya i-add dito sa 331 meters per second. So, 0.6 meters per second degrees Celsius times 22 degrees Celsius plus 331 meters per second. The answer will be 344.2 degrees Celsius. Another sample problem. Calculate the speed of sound if the temperature of the vibrating water is 25 degrees Celsius. So again, we're going to find the speed of sound. Using the formula, V is equals to 331 meters per second plus 0.6 meters per second degrees Celsius times 25 degrees Celsius, which is given in the problem. So before we compute for the speed of sound, let us first multiply 0.6 meters per second degrees Celsius times 25 degrees Celsius. And then, after multiplication, we're going to add 331 meters per second. So the answer will be 346 degrees Celsius. As for your assignment, answer your learning task and learning activity sheets in your Google Classroom. That ends our discussion. I hope you learned something new in my discussion and see you again next week.